Hello everyone. In this video we're going to be taking a look at inequalities and interval notation. I'll be explaining what that is for the very first time. Think of this as a normal lesson, as in taking notes, trying the practice problems that we do together, and really this is to get us ready for class on Tuesday. So any questions, I'm going to remind you again at the end, please submit in the Google form. That gives me a good idea of where to start on Tuesday and how well you guys understood everything featured in the video. So get prepared, have something out, piece of paper, notebook. Don't necessarily need a calculator, but get prepared for the rest of this video. Enjoy. Alright guys, so we're going to dive right into this. We're going to be talking about solving and graphing inequalities first. This should be a little bit of a refresher. Very, very similar to equations. There is a slight twist, if you remember, particularly when we multiply or divide by a negative. But comparing it to linear equations, the process of combining like terms, distributing, moving things from one side to the other, almost identical. And we'll talk about that negative feature when it does come up. This is usually in the last step. So let's get started. We're going to distribute. There's a little refresher on the bottom about what the symbols are, in case you're a little rusty with that. But I'm distributing a 5 here. I could also see that I have a case of variables on both sides. So before moving things, I usually like to combine what I can first. I see that there is something I can combine on the left. I'm going to make that 7x now. And while I would probably usually bring the 7 to the right here, I'm going to purposely bring the 13 to the 7. Nothing wrong with that anyway. And being that I'm bringing my variables to the left, I'm going to bring my constants to the right. I like to do this all in one move. Okay, on the left, let's be careful here. We get negative 6x. And on the right, we get 24. And now at this stage, this is where we usually divide by the coefficient. In other words, it's saying negative 6 times x. So division will undo that. Negative 6 divided by negative 6 is 1. I have to balance it out. And I'm just going to write to the right here. I get x. 24 divided by negative 6 is negative 4. However, even though we started with a less than sign, less than symbol, I'm now going to write my answer as greater than. Why am I just kind of randomly doing that? When we multiply or divide by a negative with inequalities, we flip the sign to maintain the accuracy of the inequality itself. If you really want to be concerned about why we do that, you could break it down very simply with just numbers. We all agree that 3 is greater than 2, correct? But the second I introduce negatives to this, this is no longer true. If I were to keep it the same. For me to maintain the validity of that, I'm changing the direction of the sign. That's a very simple explanation, but it makes a lot of sense. Now, if I did want to graph this on a number line, we don't really stress in Algebra 1, graphing things on number lines, but also a good refresher, I suppose. I like to put the number that I got in my solution set right in the middle, one number on either side to give a sense of direction. I'm going to indicate 4 with an open circle. In other words, negative 4 itself is actually not an answer. X cannot equal negative 4 here. And I'm going to shade to the right. So what this is saying is every value of x that's larger than negative 4 is in the solution set. So this is another difference with inequalities and equations, whereas we don't just have one solution, we have literally an infinite list. Everything on the right-hand side of this number line is going to be a valid solution here. We can check, we can plug in something as simple as negative 3, something as simple as 0 even, just to make sure that we shaded correctly and then we solved it correctly. So this is a little recap on how to solve inequalities. And this is a little note slide. Feel free to jot down what you like here. If you're more familiar with this and you feel like you don't need this refresher, you could still kind of watch this now, but you don't necessarily have to write down everything. The star here is very important. This is something that people forget. Even as you get into higher level math classes, that simple rule that you learn in 6th grade, 7th grade, might be something that slips your mind. It also works for multiplication. People tend to think it's just through division. If I ever multiply by like a fraction, let's say, that's negative, same rule applies. I flip the direction of the sign. Less than becomes greater than, etc. When we're graphing on a number line, open versus closed circle. When I say open circle, like the last example, that's saying, hey, this is not an answer. Versus a closed circle, I'm saying on that particular value, this is a valid solution. A little trick with deciding where to shade, if your variable is written on the right-hand side, the left-hand side, the symbol itself is kind of pointing where to write. So let me explain what I mean. If I say like x is less than 3, when I'm shading this on a number line, at 3, I'm going to shade to the left. Obviously, there would be an open circle there. Think about, like I said, this symbol itself being an arrow, it's pointing to the left. That only works when you write your variable or when you write your solution the normal way, like I said, with the variable being on the left-hand side. And that's what that little note says on the bottom. All right, and this is the real new component for today, interval notation. So I want everyone to jot these down, pause it if you feel like you're not fast enough by the time I change the slide. This is new. Just kind of explaining what's going on here before we see it in motion. This is an alternative way to write things. Like, for example, the one we did earlier, or anything, we got something like x, and we wrote our answer like this. I know this wasn't the answer, but when we solve inequalities, we traditionally write them like that. This is a different or new way to write solution sets. Like I said, it utilizes brackets and parentheses where they actually make a big difference. We usually kind of use these words interchangeably in math with order of operations, brackets, and parentheses. Really the same thing. They're both grouping symbols, but they make a very big difference here. We're going to utilize brackets kind of like a closed circle. Brackets indicate that that number is equal, meaning it can actually be that value. So that would be in comparison to your less than or greater than or equal to symbols. Parentheses are kind of like the open circle of this scenario where they're not included. So those are your less than and just standard greater than symbols. Now a little preview before we actually try some. This makes a lot more sense when you see it in motion. The example I gave on the bottom there, x is greater than 8. In interval notation, it would look like this. I know this is mind-blowing seeing it for the first time. Now, first observations would be, hey, that looks like a coordinate. Now, what this is saying is kind of like an interval or a range. It's saying, hey, the answers here go from 8. Now, remember, parentheses means it can't equal 8, which makes sense based on my symbol. So, hey, not touching 8, but the 8.0001 is a solution, the closest tick to 8. And obviously, this is going to go on forever. So notice on the right, sideways 8 here, an infinity sign. This is saying, hey, 8 to positive infinity is the solution set here. With infinity, we always use a parentheses. Should add that as a note. With positive or negative infinity, we always use parentheses. The best way of thinking of that is you can't equal infinity. Okay, we wouldn't want to put a bracket there that's saying, hey, we can equal the idea of going on forever, which doesn't make much sense. So let's see this in motion, but on this slide, all it's important to kind of jot down these two notes, and let's see it in practice right now. All right, so we're going to take these from inequality notation to interval notation. And the first one we're looking at says x is greater than 5. So let's think about what this means right now. Right now, this means 5 itself is not an answer, but everything larger than 5, all the way to positive infinity, right? Things like 3 billion are in the solution set here, technically. Now, in interval notation, I'm going to start at the lowest value. When I read in interval notation, I'm really thinking small to big. In other words, what's the smallest possible answer on the left? On the right-hand side, what's the largest possible answer? So in this case, the smallest possible answer is not 5, but parentheses 5. That's me saying, hey, open circle there, not really touching 5, but right there, basically, the next smallest possible number after 5. And this is going to go all the way up, comma, to infinity. And again, I'll add a little note here. This goes from smaller to larger. One common mistake that I see a lot, and it's a minor one, and people don't get, hey, it's, what's the big deal? People are writing an answer like this. They're going, hey, it's the same window. I'm saying infinity to 5. This doesn't make sense based on what I just said, right? This does not go from small to large, from left to right. Just like we read a book, we're going to talk in left to right language. All right, let's try the second one. This says x is less than or equal to negative 8. So let's think about this. What is that really saying? So negative 8 is now an answer. Can equal negative 8, and everything's smaller than that. So remember, we go small to large here. The smallest possible answer here is actually negative infinity. So I'm going to put a negative infinity sign, right? This is going to keep getting smaller and smaller and smaller, negative 10 million for all I know. And the largest answer, comma, is negative 8. These actually look similar, negative infinity and negative 8. And next to negative 8, this is our first time using it, we're going to put a bracket. The difference between that bracket and a parenthesis, such a seemingly small difference, is very important. Now I'm saying, hey, this can equal negative 8. And again, left to right, it goes smaller number to larger number, giving me a little window. Hey, all the way from negative infinity up to a maximum value of negative 8. And last but not least, we're going to talk about compound inequalities on Tuesday. Basically, I kind of call this an inequality sandwich. What this is saying is really two things at the same time. Hey, x has to be greater than or equal to 1, but at the same time, it also has to be less than or equal to 10. So it's kind of sandwiched between those two numbers. So how I'm going to write this, no infinity involved here. This does not go on forever. It's kind of capped on both sides. I'm going to write bracket 1, comma, 10, bracket. This is saying, hey, this window goes from 1 to 10. I put brackets on both sides because of these equal to components. And that's translating to interval notation. Most important thing, small to large, knowing when to use a bracket, when to use a parentheses. Recall, we always use parentheses with infinity symbols. A bracket next to parentheses would be something that we would be technically inaccurate with. And last but not least, we're going to take a look at translating from interval notation to our standard inequality notation. So seeing something like number 1, if we didn't explain all this, you would probably have no idea what that's saying, right? Looks like a coordinate, but it has a weird bracket. Why is there an infinity sign? But now that we have a little bit of a base level knowledge with this, what is this saying? So small to big, this is saying, hey, the answer is 6 to infinity. And it can equal 6. I know it can equal 6 because I see a bracket here. So what that's telling me right away, I know it's going to be or equal to. I also know it's going to be greater than or equal to. Because, this is representing values that are larger than 6 or equal to 6. So 6 is greater than or equal to, x is greater than or equal to 6. For number 2, I see two parentheses, so I shouldn't have any equal to component in my symbol. I also see this is one where we have negative infinity. This is telling me it's going to be less than. This is something that's getting smaller and smaller, and it does have a maximum at 3. So I'm going to say x is less than 3. Okay, again, no equal to. I don't see any brackets. It's less than because we're getting into negative infinity. And we have another compound inequality here. Notice no infinity. This is another sandwich. So we're going to have x in the middle and two symbols, one on the left and one on the right. Now 4 to 9, obviously just like with everything, we go small to big. 4, it can equal 4. It could be anything larger than 4. It could also equal, I'm looking at the bracket here. And with 9, I'm just going to put a less than sign. So both of these are representations of saying, hey, x is kind of bound between 4 and 9. The symbols can be different in a compound. You notice I have one that has an equal to slash, the other one doesn't. That's fine. There's no error there. And that's my inequality translation. So this video recapped some basic background knowledge with solving inequalities while also introducing something new in interval notation. When you come to class on Tuesday, we're going to practice actually solving. And when we solve, the idea is to write our answers in this interval notation. Obviously, questions aren't going to be as cut and dry as these last two slides. It's just that now that we know what it is, we're expected to write our solution set as such. And if you have any questions, anything didn't make sense in this, in the Google form linked with this video, please submit them there. That gives me a good idea of where to start Tuesday and things I can maybe cover again in person. Thank you all for watching. Have a fabulous 3-day weekend.